Have you ever really stopped to think about how a search engine works? I mean, how does it take the absolute chaos of the internet and just find the one thing you need? Well, the answer goes back to a beautifully simple but deeply flawed idea called PageRank. Today, we're going to pull back the curtain on how it works, where it completely falls apart, and how one single clever fix not only saved it, but created the personalized web we use every single day.
All right, so here's the game plan. First, we'll look at the core idea, the web as one giant voting system. Then we'll see exactly how that system breaks down, catastrophically. After that, we'll introduce the elegant teleportation fix, see how that opened the door for personalizing everything, and finally, we'll dive into the never-ending war against web spam. You have to remember, the early web was a total mess. It was like a library with all the books thrown on the floor and no card catalog. Finding anything reliable was next to impossible. We desperately needed a way to sort through the noise, and the founders of Google came up with a truly brilliant way to do it. So, this is the fundamental question, right? With billions of pages out there, all trying to get your attention, how can a computer possibly figure out which ones actually matter? How does it separate the gold from the garbage? The big idea was to treat the web like a massive election. Every link from one page to another is basically a vote. But, and this is the crucial part, not all votes are created equal. A vote from a super important site like a major university is worth way more than a vote from my cousin's blog. So your importance isn't just about how many votes you get, it's about the importance of who is voting for you. It's a beautiful, elegant concept, but it had two huge system-breaking flaws. And I'm not talking about little bugs. These were problems that could make the entire ranking system just collapse into uselessness. So let's meet the two villains of our story. Okay, on the left, you've got dead ends. Pretty simple. These are pages that have zero outgoing links. Think about a random surfer just clicking around the web. When they land on a dead end, there's nowhere else to go. Poof, they fall off the web, and all the importance or rank they were carrying just disappears. On the right, we have the spider traps. These are way more sinister. It's a page or a group of pages that only link to themselves. Our surfer gets in, but they can never ever leave. Now, watch what happens with a dead end. In this little network, everyone starts with some rank. Pages A and B pass their rank along. But once that rank hits page C, the dead end, it has nowhere to go. It just leaks out of the system. It's gone. And if you run the simulation long enough, that leak drains all the importance out of the entire web. Every single page ends up with a rank of 0. The whole system fails. And here's the spider trap doing its thing. Keep your eye on page M. On the first pass, it gets rank from other pages. But because it only links to itself, it never lets that rank go. It just hoards it. With every single cycle, it just sucks in more and more rank until it has basically all of it. It becomes a rank black hole, and the rest of the web becomes worthless. Again, the system is totally broken. So the system's broken. It's a disaster. What do? Well, the solution is just pure genius in its simplicity. It's a single idea called teleportation, and it fixes both of these fatal flaws in one go. We just give a random surfer a new choice and new superpower. Most of the time, let's say 80% of the time, they do what they always did. They click a link on the page they're on. But the other 20% of the time, they just get bored. They ignore all the links on the page and randomly jump or teleport to any other page on the entire web. And here's how that looks in the formula. Don't let the math scare you. It's actually super simple. The rank of a page is now 2 parts. The first part is the old way, the rank you get from people following links, which happens about 80% of the time. The second part is the new teleportation magic. It's a tiny little slice of rank that every single page on the web gets for free, because there's always that 20% chance our surfer could randomly land there. That tiny addition changes everything. So why is this so powerful? Because now our surfer can never get permanently stuck. If they hit a dead end, no problem, they'll just teleport out. If they get caught in a spider trap, eventually they'll get bored and teleport out. This one simple trick guarantees that importance, that page rank, can always keep flowing across the entire web. The system is saved. But here's where the story gets really, really cool. This fix wasn't just a patch to stop the system from breaking. It was actually a key that unlocked a feature that defines the modern web: personalization. Someone had a brilliant thought. What if the teleportation wasn't completely random? What if instead of jumping to any page on the web, our surfer only jumped to a specific set of pages that we know a user likes?
maybe pages they've bookmarked or pages about a topic they're interested in, like sports or cooking. This is the core idea of what's called biased PageRank. And just look at the result. It's amazing. We have two users. User 1 likes pages 1 and 2, so their teleportation is biased towards those. For them, page 2 is clearly the most important. Now look at user 2. They like pages 1, 2, and 3. That one small change in their preference completely changes the rankings. Now for them, page 3 is the most important. It's the same web, the same link structure, but two totally different personalized results. Now you might be thinking, there is no way they can recalculate the entire web's ranking for every single user. And you'd be right, except for some incredibly clever math. Basically, instead of starting from scratch for you, they pre-calculate a bunch of elemental rankings for people who only like sports or only like tech news. These are the basis vectors. Then, your personal ranking is just a super fast mix of these pre-made results. It's like mixing primary colors to get your exact custom shade, instantly. Of course, the moment you create a system that assigns value, people are going to try to game it. And that brings us to our final chapter. The endless, high-stakes war between the people who rank the web and the people who try to manipulate it. One of the primary weapons for spammers is the link farm. The strategy is actually pretty simple. You create a giant network of websites that you control. You make every single one of those pages link to your one target page. Then you just need to get a few real links from the outside web pointing into your farm. The farm then acts like a giant amplifier, a focusing lens, funneling all that page rank to your one target. And get this, it's not just a small boost. The math shows that with a standard teleportation value, a perfect link farm can amplify any incoming page rank by 2.7 times. That's a huge unearned advantage. It's basically weaponizing the algorithm against itself to rocket a spammy page to the top of the search results. So how do you fight back against that? Well, you use the same tool, Biased PageRank, but this time it's called TrustRank. The idea here is, instead of teleporting randomly or to a user's favorite pages, we only teleport to a small, hand-picked set of universally trusted websites. Think major universities, government sites, big news organizations. The fundamental assumption is that these trusted sites aren't going to link to spam. This gives us a new weapon. We can calculate a page's spam mass. Here's how. You run the normal PageRank calculation. Then you run the TrustRank calculation. The difference between those two scores tells you how much of a page's importance comes from sketchy, untrusted neighborhoods of the web versus the trusted parts. If a page has a high spam mass, that is a giant red flag. And that leaves us with a really big question for today. PageRank was built on a very human idea, that a link is an editorial vote of confidence. But what happens when AI can generate millions of pages and fake links in a split second, when spam is more sophisticated than ever? This old system of trust is being pushed to its limits. Figuring out how we decide what and who is truly authoritative online, well, that's one of the biggest challenges for the future of the entire web.